Have you joined? Can you hear me? Can you hear me, Durgara? Hello?
Yes, sir.
Okay, screen is clear now? Screen.
Visible, sir.
Okay. So we'll start, we'll continue with yesterday's class. Okay. So types of fits we have come. So I'll just try to go for two PPTs today. Two alternatively, so I can understand which is better. We'll just try to follow. So types of fits yesterday we have seen the clearance fit, the transition fit, and this one, and the interference fit, and the subclassification also we have discussed as an introduction. So we'll just try to go to that part. So types of clearance fit. So we have this one clearance fit as a positive allowance. Already I told you, and we have it gives a loose joint, and here just fits. These fits are just according to the customer's requirement. We just try to provide the desired type of fit. And whenever we are talking about the positive allowance and clearance fit, there's a positive clearance between the high limit of shaft, upper limit, high limit or upper limit is the same, and the low limit of the hole. So that is how we can just clarify or justify. And as far as the rotation of the shaft in the hole, it allows rotation or sliding between the mating parts. So this is the clearance fit, and in clearance fit, there's a slight airspace between the shaft and the hole. So you cannot see it by naked eye, just by visualization, we are telling that in the clearance fit there is an airspace. Okay, so that is the fit. And as far as the types of clearance fit, already I told you. Whenever he is asking types of fits, you just try to specify the clearance fit, transition fit, and interference fit. Draw the corresponding diagrams or sketches. And if he's asking classification means you have to go for subclassification also, because according to the marks he asks for short answer and big questions, you have to justify your write up. Okay. So as far as the loose fit is concerned, here in the clearance fit, there is no precision required actually, and it provides a minimum allowance. Minimum allowance. Minimum allowance means minimum positive allowance. What we mean, and we have to have the, as far as the clearance fit, it will start from the zero clearance, or we can say no clearance at all, or a little bit of clearance, little amount of clearance, and the clearance will be opening from the loose fit to the slide fit. Maybe in the running fit, it will open up a little as far as the clearance is concerned. And why we have to have this type of fit as far as the application in the industries are concerned? Because if we want to mount the pulleys on the shaft, loose pulleys, and if we want to have the mating of the components in the agricultural machinery, we have to have this type of fit. Because if you try to go for the maintenance part also, maintenance, the temporary or this, you can disassemble the components and try to overhaul the machinery, take maintenance. So you have to have a temporary fit. You can say this is a clearance fit is a temporary fit. But when we try to compare this clearance fit to the this interference fit, where we have the negative allowance there, it is a permanent assembly. Permanent assembly. So you try to understand or try to just know that part as far as the maintenance are concerned. Because for overhauling of the machines, overhauling means just greasing or periodic maintenance we have to have for the agricultural machinery or any other equipment in the industry as far as the machines are concerned. We have to have this type of fit. So as far as the running fit is concerned, the dimensions of the shaft should be smaller. Why? Because there should be a thin film. There's a light clearance. Prescribed amount of clearance is provided between the shaft and the hole. And in order to have that, because for lubrication, if you want to have a thin film, want to maintain a thin film of oil between the mating parts, because without lubrication, there will be a wear and tear. There will be friction between the moving parts, because the moving parts, there will be friction and there will be wear and tear, and that's why you have to provide lubrication. So here in the running fit, it is used in the bearing pair of bearings, just pair of gears. We try to say for effective power transmission as far as the gears are concerned. Here also in the running fit, we try to use this in the bearings, different types of bearings, pair of bearings, not a single bearing, but pair of bearings. So as far as the third type is concerned in the subclassification, we have the slide fit or the medium fit. Slide fit or the medium fit, and it is used on the mating parts where great precision is required. You just try to see. No precision, not much precision is required. It is a loose fit, and sometimes in some of the textbooks it is loose running fit. This second one is the slack running fit, and the third one is the slide fit or medium fit. You don't try to confuse yourself, but you just try to say the clearance will be opening from 0 to a medium amount, and for the slide fit or medium fit, where great precision is required, it will be allowing some medium allowance. Okay, slide fit also medium allowance, but where it is used mainly in the assembly of the machine tools. Machine tools, we have the tool slides, no, where the movement of the tools are there. The cross slide, mount the tools on the cross slide in the lathe machine, or the slide valves or the automobile parts. So we have to have this slide fit or medium fit. So you have to give some examples, not only just writing some literature or supporting literature. You have to quote some examples. Okay. So different definite examples are there in different textbooks. You just try to follow. So as far as the interference fit is concerned, we'll just try to repeat this in another slide, another PDF. It's also there. You just try to see that. So here in this particular interference fit, we have the negative allowance. Negative allowance, that means a negative difference between the diameter of the hole and the shaft. So if it is a negative allowance or negative difference between the diameter of the hole, it's called interference. That means the diameter of the shaft is more than the diameter of the hole. In such cases, it is given that the diameter of the shaft is always larger than the hole diameter. So in this, it is used for components where the power has to be transmitted, where motion or power has to be transmitted, and it is opposite of clearance. That's why sometimes we can say interference is equal to negative clearance, or you can say just like already I told you, in clearance also we have the maximum clearance and the minimum clearance, and via media a particular slide fit or medium amount of clearance and medium amount of allowance are provided in the tool slides or the slide valves or the particular automobile parts, here it is the maximum interference and the minimum interference. So here, as far as the classification is concerned, I'll try to explain you in the other slides also, where we have to provide the maximum interference and minimum interference, and it is opposite of clearance, where it's starting from zero clearance to it is opening up, but here it will be the maximum to minimum. Maximum to minimum. You can say maximum means maximum negative allowance, and as far as subclassification is concerned, it is the last subclassification is the minimum negative allowance. So that you have to just specify. And interference which exists between the high limit of hole, just try to see upper limit of hole and low limit of shaft. So it's the opposite of clearance. And here in the types of interference fit, we have the different types. That is the string fit. Already I told you it starts from the maximum negative allowance. So in the assembly of these holes and shafts, what happens is the hole is expanded by heating, and then it is rapidly cooled in position. Because just try to take an example of the steel rim, which is fitted on the bullock cart wheel. This is an example fitting of rims, and that is a classic example. And you can say the string fit also is applied in the strength of materials part, where in the compound cylinders, the outer cylinder is fitted onto the inner cylinder just by this one, the thermal expansion, and then we'll try to cool it in position, and then the mating takes place and the assembly takes place. That is a string fit. You can give that example also, the compound cylinders example. And as far as the second classification is concerned, second type, it is the medium force fit. Medium force fit. So here in this we have the medium negative allowance. So we have to apply considerable amount of pressure to assemble the mating components. So that is how you have to say, and it is used in car wheels and the armature of dynamometer. Armature of dynamos, not dynamometer. Dynamometer is different from dynamometer. Dynamometer is a electrical dynamometer, mechanical or whatever it is. We have the dynamos in the electrical technology. The armature, we'll try to fit it on that one, on the outer periphery of the wheel. That is the armature of dynamos. So here in the force fit or tight fit, you apply more amount. You try to if you just try to apply little pressure, a little amount of pressure, because it's slight negative allowance. Slight negative allowance, or you can say it is a minimum negative allowance between the mating parts. So here it is a semi-permanent fit, you can say. As far as the semi-permanent fit means, suppose it is a permanent assembly, not the temporary assembly, already I told you, as far as the interference fit is concerned. So that the keyed pulley and the shaft, you can have the keyed pulley on the shaft by applying a little amount of pressure, a little amount of force. So that is how we can say, and the rocker arm also. Rocker arm. So you can have different examples. So if you quote examples, the examiner thinks that you have a fundamental knowledge, and you try to explain with respect to the particular. I'll just try to explain another PPT that what is the type of speed also, the speed of the spindle or rotation or whatever you just try to say. So that is very important. So transition fit What is transition fit? It is via media between the clearance fit and the interference fit. So actually, this depends on the actual values of the individual tolerances. Because we can say in another way, we can say that it is a compromise between the clearance and transition fit. So wherever applications are needed, specific applications, industrial applications, where accurate location is important, you either opt for the small amount of clearance or interference. That's how we can just specify as far as the transition fit is concerned. You have to draw the diagrams, my dear friends, and you have to say that you draw clearly, because you can see this particular part is not matching with this line. It is either clearance or interference. So you just try to observe the different diagrams related to, if you want to explain the types of fits, clearance, transition and interference. So as far as the types of transition fit are concerned, we have the push fit or snug fit. We just try to see push, force, ring. So here also we are starting just like the clearance fit, we are starting from the zero allowance, because in the first classification of the clearance fit, we started from the minimum clearance or zero clearance actually. We are opening up the clearance in the different classifications. Okay. And here we have to apply light pressure. We want to assemble the hole in the shaft. And we have to see that we have to minimize the vibrations also, mechanical vibrations between the moving parts, because if there are more number of vibrations or there's insufficient lubrication between the moving parts, there's a wear and tear, and you have to replace the moving parts in a shorter period of time. So that's how we can just explain. And in the first fit, these are rigidly fixed, and one cannot move toward the other. That means either it requires high pressure to force the shaft in the hole, that's why it's known as force fit. Or if you want to, just like the string fit, you just try to say the string fit is all there in the interference fit also, but here you just try to specify only one type, push fit or force fit. Don't try to specify in the transition fit, string fit. You may have given here in the PPT, but you just try to go back and just try to say, because here whenever in the interference fit, instead of people have forgotten string fit, they try to say heavy force fit, medium force fit, and simply force fit. But you try to come like this: string fit, medium force fit, and tight fit, where the permanent assembly is there, and you cannot disassemble the components whenever for a life period. If the particular components inside the machine, the mating components will run, they will run up to that period, and after that, if there is any problem, because it's a permanent assembly, you have to just replace the machine with another machine. Okay. So you cannot replace the component just like in clearance fit, because it is a temporary assembly there. And here, that's why I just gone back. So push fit, force fit, and bringing fit. You just try to remember like this. So in the middle one, he has given in the interference fit, medium force fit, but here it is the only force fit, where you cannot move the components with respect to the other. Because if we want to move also, we have to have apply the high pressure or heavy force, or you have to expand the hole by heating. So you can give the example of railway wagon wheels. Here, okay. So as far as the ringing fit is concerned, we have slight negative allowance. Rather than the clearance here, because the transition fit either clearance or interference is there. Here the interference part will be dominating the clearance, or it will play more active role, and we have the slight negative allowance between the mating parts and the ringing fit. So here we have to have apply more pressure to force the shaft into the hole, or we have to have a light assembly. So it is here, it is used in fixing keys, shafts, shaft couplings are there now, and you have drawn different types of keys in the machine drawing. So here it is used in fixing keys, pins, etc. So whenever you want to assemble the mating components, that's how we just try to see this part, and we'll try to go for a new share now. I'll stop this share. I'll just try to, again, if you want, we can just have this. So we'll just try to go for the new share. That is the more explanatory things are there in that. We'll just try to see that, okay? So I'll stop share and then go for the new share now, okay? So I think we have to just minimize that part. So here in this particular PPT, again we'll just try to have the revision of the types of fits, or second expansion of that whatever we have learned in the types of fits, because I thought it was better. Yesterday also we have just seen the unilateral system and the bilateral system. I'll be sharing all this in the weekend or after the chapter. So you just try to follow which one is better, but you just try to expand because some people are writing just few lines and not drawing. You're seen in the metal cutting and machine tools, where we've gone for spot valuation or just like chief examiner, whatever it is, but not so particular result, maybe between not more than 70, because 8 people will be just 7 or 8 people or 6 or 8 people will be correcting. Maybe I'm only telling about the set 3. So here we'll just try to talk about the different types of assemblies after this one. By giving some examples, so you can understand better the difference between the interchangeable assembly and this one. So here in this yesterday, I want to tell this also before going to the types of fits, because yesterday we have just discussed about the upper deviation and the lower deviation, but here the fundamental deviation is also very important, because it is the upper or lower deviation which is the nearest one to the zero line for either the shaft or the hole. You just try to see this. So here in this figure we are specifying the lower deviation as a fundamental deviation, and the tolerance zone is above the zero line here. So whenever we are having the lower deviation as the fundamental deviation, I want to specify this also. And whenever we are going for that upper deviation as the fundamental deviation, the tolerance zone is below the zero line. You just try to remember this. This is the fundamentals, because without this you cannot understand the hole basis system and the shaft basis system. Okay, those hole based system, shaft based system, types of assemblies. Those are the important topics. Types of fits, unilateral tolerance, bilateral tolerance. So you can note down. So here I want to just explain the basic shaft also. Simply shaft we have explained, but here the basic shaft is here. The upper deviation is 0. Upper deviation means here the basic shaft is denoted by the letter H, small h. You just try to remember. For shaft is the small letters, and for hole it is the capital letters. So as far as the here in the basic shaft, the upper limit of the basic shaft is the same as the basic size. So you have to just give your definitions. So these are all the fundamentals. It may be asked in the short answers or viva versa in the lab, but basic fundamentals you have to learn about the limit splits and tolerances. So what is the basic hole? Basic hole is the hole whose low deviation is 0. So here the lower limit of the basic hole is same as the basic size. So it's denoted by letter H. So if anybody asks what is the basic hole, you can say simply letter H, but you have to say there the lower deviation is 0. So that's why I specified the fundamental deviation there. And here, as far as the definition of fits or types of fits, they are long back they were defined, long back they were designated. As far as and the Indian standard is 919. If you don't remember, but just try to know that because the standards are there. As for the international standards or the ISO standards, we have to know that part. It's not history, but as long back in 1963, it was defined. So it is a degree of tightness or looseness. Yesterday we have seen that definition of fit also, degree of tightness or looseness between the mating components. Because you have to perform a definite function when they are assembled together. So already I told you, without performing a definite function, there's no definition of fit or there's no meaning of fit. Just like writing a C program without any logic. It's not working, there's no use. And here, the result, this particular fit may result in a mobile joint or a fixed joint. Already, according to the types of fits, we can say fixed means you can just observe now because it is a permanent assembly. Mobile joint is either the clearance or transition. So, for example, he has given a shaft running in a bearing. So you can run, it can move in relation to it, but and it forms a mobile joint. You can say shaft running in a bearing as far as the mobile joint is concerned. But whenever you want to assemble the pulley, permanent assembly mounted on the shaft is a fixed joint. It is a fixed joint. So you have to give quote some examples regarding the types of fits and the basis of the positive allowance and negative allowance. There are 3 types of fits: clearance, interference, and transition. Just somewhat a revision because it is another slide, we can say, another PPT slide. So just because anybody, that's why I'm showing, because it's just a good way of presentation. This in this part, in this slide. So clearance fit, interference, transition. You can shift transition in the middle and interference this side like that. And in this classification, just same, but just try to remember like this: easy slide fit, running fit, slack running fit, loose running fit. I already told you we have that 3 types as far as the running fit is concerned. So same, whatever previously I have discussed in the interference fit, force fit, tight fit, string fit, and the transition fit, push fit, and ringing fit. So here already might have been known by now. The largest permitted shaft diameter is smaller than the diameter of the smallest hole in the clearance fit. The shaft diameter is smaller than the hole. Okay. So here you can say that the shaft can rotate or slide through. Because we have to specify the degrees of freedom also. How many degrees you want? Whether you go for 3 DOF or 6 DOF, degrees of freedom, 3 linear or 3 rotary. So according to your particular application, that you have to specify. So just try to see the clearance fit, how he has given the diagram. So the shaft diameter is smaller than the diameter of the smallest hole. So just try to see. This is the clearance. This is the clearance. So I don't have to draw this, but I just try to explain. So every time you have to draw the zero line. Zero line is very much essential in the showing the types of fits, and even in the shaft-based system and hole-based system, I'll try to explain you at that point of time how you have to, in a one single diagram, how to, as for the shaft basis or hole basis, how to specify the three types of fits. He's asking in the JNTU, especially in the JNTU papers. You just try to see previous papers R13, R16. So here R16 only. And here in the interference fit, the minimum permissible diameter is larger than the maximum allowable diameter of the hole. The shaft diameter is larger than the hole. So we have seen examples, we have quoted some examples: bearing bushes, steel rings on wooden bowler cart wheel, steel rings or rim, we can say. They are in the form of a ring only, but in the strength of materials, you might have studied the different types of stresses, that is the hoop stress and the radial stress. That particular part, the stress is in a thin ring or wheel, you can say. So interference fit, you just try to draw like that. The diameter of the shaft is more than the diameter of the hole. So that's why this interference part, you can just see the difference in the diagrams between clearance fit and interference fit. This interference, this part will go above the hole. So just try to see that the difference. And every time I am specifying, zero line is very important. And it's a simple diagram as far as the interference fit is concerned. And you try to explain the subclassification as far as the interference fit, just like the previous slide. If you want me to repeat, I'll repeat again that particular slide. Okay, so transition fit. Anytime you can say it is lying between the clearance fit and interference fit, or I can say it is a compromise between the clearance fit and interference fit. And in this type of fit, here, what you are telling, the largest allowable hole is greater than the smallest shaft, and vice versa, because either you are giving clearance or interference, but the smallest hole is smaller than the smallest hole is smaller than the largest shaft. You can say that both the positive and negative clearance exist between the shaft and the hole. Okay, clearance. There's a difference between tolerance and allowance. I'll just try to specify you, or just to show you in one of the slides. He is asking for 2 marks in the examination final. Difference between tolerance and allowance. So spigot in mating holes. Spigot, you may be not knowing, it is just like fixture. In the industry we have seen where we have to mount a component or the workpiece on the spigot and try to clamp it and go for the external machining, the rough OD turning, the rough OD machine. One day, two-way or two-pass machining, we can say, just like multi-pass welding. Small amount of material is removed in one by giving a lesser feed or depth of cut, and in the other cycle or in the other spindle, by fixing the spigot or on the chuck, on the 3-jaw chuck, we can just go for more amount of metal removal to get the final rough OD diameter as per the drawing. So that practically we have seen in the industry as far as the rough OD turning machine for a automobile piston. So that we we can say. So just try to see this, because it is a compromise between clearance and end field. How he has drawn the diagram. So it is like this, the hole, the shaft, and here it is a positive clearance. Okay. So that is how we can just specify. But in the transition fit, you have to specify both the positive and negative. Here it is a positive, here it is a negative clearance. You can just try to examine how he has done. So this part, the shaft part is beneath the hole here, the positive clearance, and here the shaft part is above the hole. This part, this particular reference, not reference, I will not say reference line, because already I told you zero line or reference line, or just like the axis line, but here it is the outer periphery of the shaft. Here it is the negative clearance. So you have to draw both these diagrams as far as the transition fit is concerned. Because by drawing this, what you are telling, the diameter of the the diameter of the largest hole is greater than the smallest shaft. And the next one, what you are telling, the smallest hole is smaller than the largest shaft. That's why you have to specify both the positive and negative clearance in both the diagrams, or the positive clearance and the negative clearance. That's very much important, because if you draw, it will convey a lot of meaning in metal cutting and machine tools. Explaining that, I told you 50% weightage will be given for drawing. You see the drawing, then you know you are good at fundamentals, not in drawing, but you are good in just conveying your fundamental knowledge. And then you can explain by way of some 3 or 4 sentences or something. So according to the marks, some people are beautifully presenting, even it is a theory paper, but metal cutting we have problems only. But even that simple problem, people are not able to do successfully. So maximum clearance, we have maximum clearance is what is the difference between the minimum size of the shaft and maximum size of the hole. So just try to see that. And minimum clearance is the difference between the maximum size of the shaft and minimum size of the hole. That's why in clearance fit you have to explain this maximum clearance and minimum clearance also. So that is very important. And this is a very important part where in the special types of fits, it's not that you deviate from the original classification, but he has given here just different types of fit. Suppose slide fit is there, it will come under clearance fit. So you can explain that very small clearance is between there, or coming from the slide fit, minimum clearance is 0, starting from the 0 clearance. So where they are employed, slide fit, where the parts are required to move slowly in relation to each other, slow motion. That's why the speed of the spindle is very important while designing this type of fits with respect to the design parameters or machining parameters. It is a clearance type of fit, the slide fit. You can give a lot of examples, tail saw, spindle of lathe. You can say that the feed movement of spindle quill in drilling. That's also an example of the slide fit. What I have observed in the pillar type drilling machine. We have conducted that experiment, drilling a hole and then going for threading, internal threading. So all that are the examples. So just try to remember what you have done in the machine tools lab. So in the driving fit, what it is the interference fit. So here the shaft is made slightly larger than the hole. So they can be assembled with a large amount of force, because the permanent assembly as far as the mating components are concerned. And they are employed whenever the mating components are required in a fixed position. We have explained in the introduction part in this slide, this PPT itself, this PDF. So these are combination of this. So where mostly these are used in the industry. So here also in the push fit you have seen previously in the previous slide, previous PPT. This is a close fit which permits assembly of parts by hand. Just small pushing. That means what is the meaning of this? Here you are providing a small clearance. Small clearance. Clearance means here you can understand it is a transition type of fit. Either it may be a positive clearance or negative clearance, depends upon the customer's requirement. So just try to design this. Change gear mechanism. What we have seen in the lathe, that is to have different speeds for different operations, lathe operations. So the fourth one is the force fit or press fit. This is an interference fit. Mostly has given the good examples here. The forging machine. The forging machine there, the shaft is there now. You might have just seen in the production technology. Mechanical working or metal working. Here the force fit is employed when the mating parts are not required to be disassembled during the total service life. So what is the meaning of this one? Permanent assembly. So this assembly, how we can obtain? Only when we apply a considerable amount of pressure. So that's the example we can give. And here the tight fit. Don't say selective fit, maybe not remember, because already tight fit we have just specified in the earlier slide. So it provides less interference than the force fit. So just try to see here interference is more, but when we compare to the tight fit to the force fit, here we having less interference. That's why we have start from in the classification of the interference fit maximum negative allowance to the minimum negative allowance. But it is not the case in the case of the clearance fit. From minimum to, you can say minimum positive allowance to maximum positive allowance. There it is quite different, opposite of that. So here already I told you this tight fits are employed for mating parts that may be replaced. So we want to go for some maintenance. Mostly you can quote an example of cylindrical grinding machine. As far as this is concerned, this is tight fit. So tight fit will come under interference fit. So you try to remember tight, force, and driving fit will come under interference type of fit. So shrinkage fit. So shrinkage here already we have quoted bullock cart, steel rim on the bullock cart wheel. We have quoted examples regarding the assembly of the outer cylinder onto the inner cylinder. So if you want to expand the hole, you heat it. After cooling, then only you can assemble. Not cooling drastically, but just try to say the heated part. After heating, a considerable amount of temperature is there according to the material you use for that particular cylinder or the bullock, the steel rim. You try to assemble that. So here considerable amount of force is necessary in the fitting of frame on the rim. How it is obtained? By heating the frame and then rapidly cooling in this position. He has given rapid cooling, but you have to see by practical experience, you can see how and when to assemble. So it is a interference type of fit, distinct fit. And he has given the freeze fit, but here mostly it is not specified in most of the textbooks, but the shaft internal member, here it is contracted, contraction and expansion by cooling. And it is assembled with the hole, external member. The shaft will be the internal member here and the hole will be the external member here. Here it is quite different, but you don't try to remember, but just try to, as an additional thing, because here he has given an example of the insertion of valve seat in the engine cylinder heads. In the IC engines, we'll try to use this for assembly of this parts which are exposed to the atmospheric temperature. So that is the, but here this these filters also will come under the interference fit. Interference fit. Okay. So just try to remember that. So that valve seat you might have drawn in the production drawing. Production drawing is not there. Maybe if you have drawn the assembly of the any type of valve in the machine drawing. So allowance, the main part here we are coming. Try to conclude within 2 minutes. So we have time. So it is the intentional difference between the lower limit of the hole and the upper limit of the shaft. So tolerance is as for the individual components is concerned. And here already I told you allowance may be positive or negative. Positive allowance is called clearance and negative allowance is called interference. There's given a little part you can see later. So he is giving for 2 marks. You have to explain the difference between tolerance and allowance. So you can say tolerance is nothing but a difference between the upper limit and lower limit. We have given examples of 25 mm shaft, 25 plus or minus O2, 25 minus O2 minus 24.98. You are getting 0.4 there. So allowance is nothing but, already we have seen it is the intentional difference between the lower limit of hole to the upper limit of shaft. So that is the basic definitions you just try to give as a first difference. And then you try to explain. But well, tabular form is best way of presentation of the differences. So permissible difference in dimension or size of a part is only individual component tolerance. So it's a prescribed difference between the dimensions of 2 mating parts. So tolerance is an absolute value without sign. So allowance may be positive or negative. Third one. So all that you have to be, you might have understood by now what is the difference between tolerance and allowance. And tolerance is provided because operator is not possible. Why tolerance is provided, you may ask as the fourth one. You have to say the production people or the manufacturer or the machinist cannot produce a component exactly to the basic size. Basic size, exact size is not specified here because exact size may be the actual size. You have to specify to produce a part to the basic size. The 25 mm or 40 mm is the basic. So why allowance has to be provided? You can say allowance has to be provided on the mating components, that is the shaft of the hole, to provide the desired type of fit according to the customer's requirement. So we'll just try to continue. Next class we either go for the hole-based system or shaft-based system or the types of assemblies, depending upon the sequence in the syllabus or something. So as of now, we'll try to quit now as far as this class is concerned. We try to concentrate on the topics which I am telling, which are important in the middle of the class. And so, I'll be concentrating both on the short answers and big ones. So just try to keep a track of the syllabus. Unit 1 and Unit 2, they are simple, but you have to understand and practice the definite diagrams. Okay, we'll leave. Thank you for patient hearing and we'll try to join in Monday's class. Okay, thank you.